For each of these descriptions of motion, draw the velocity time graph and find the total distance traveled. Okay, so there are multiple parts to this. Part A. A particle accelerates uniformly from 20 meters per second to 32 meters per second in 15 seconds, then moves with constant speed for 25 seconds, and finally decelerates uniformly and comes to rest in another 10 seconds. So 3 legs of motion are given to us. We need to draw the velocity time graph and find the total distance traveled, not the displacement but the distance. Okay, so to draw the velocity time graph, y-axis we assign as velocity, x-axis as time. It's saying in the first leg, the particle accelerates uniformly from 20 meters per second to 32 meters per second in 15 seconds. Uniformly means the rate of increase of velocity is constant. That means acceleration is constant. And what is acceleration? Acceleration is basically the slope of velocity with respect to time. So dv by dt, that's acceleration. So the slope of velocity time graph for these 15 seconds, that would be constant. That means it'll increase from 20 to 32 in a straight line fashion. So let's say this is t is equal to 0. This is t is equal to 15. I'm drawing the graph not accurately to scale, but if we need that, we can find the slope directly. V final minus V initial, 32 minus 20 over 15. This will be equal to 12 over 15. That is 3 times 4, 3 times 5, 0.8. This is the slope. So if you need for accuracy. So this will begin from 20 meters per second to 32 meters per second. Okay, 32 meters per second and 20 meters per second. So let's draw horizontal lines from here for guidance. This is our velocity time graph. It's a straight line, although it doesn't look like that. So AB, the range AB is a straight line increase in velocity 20 meters per second to 32, then moves with a constant speed for 25 seconds. So for next 25 seconds, that means up till t is equal to 40, it's a constant velocity. That means traveling at 32 meters per second, not increasing, not decreasing. So BC, that's constant. And then decelerates uniformly and comes to rest in another 10 seconds. So in the last 10 seconds, that means that t is equal to 50, between 40 and 50, it decelerates at such a rate that it goes from 32 meters per second to 0 meters per second in 10 seconds. Like this. This is our VT curve. So everything's done here. Now we're asked to find what's the total distance. So interestingly, in this case, the distance and displacement would be the same because there's no negative velocity. So no change in direction of motion. Hence, no negative displacement would be there. So the distance and displacement is same. We'll divide this into 2 parts. Divide the graph into 2 parts. So origin is O, A, B, D. Let's say D at t is equal to 15. Then this at t is equal to 40 is E, and at t is equal to 50 is F. So we have 2 figures. The first figure is, it's a trapezium OABD, and then the second figure is another trapezium, that is DBCF. Okay, we need to find the area under the graph. Why? Because velocity is the derivative of displacement, or displacement upon time. That means velocity is the slope of the displacement time curve. So inversely, displacement would be the area under the curve for velocity. Okay, like I've shown in other questions. So this is how we'll follow. So area of trapezium OABD, that is 1 by 2 into sum of parallel sides. Parallel sides are OA and BD. So 20 plus 32, that's a 52. Multiplied by distance between them. Distance is OD, that is 15. Then DBCF is 1 by 2 sum of parallel sides. Parallel sides are BC and DF. So BC is 25 and DF is 35. So 25 and 35 is going to be 60. Into distance between them, the parallel sides distance is BD. BD is 32. So this is going to be our total, add both of these, that'll be our thing. So 15 times 26 plus here it'll be 16 times 60, 960, and here it's 15 times 6 is 90, 0, 9, 15 times 2 is 30, 39, 390. 390 and 960. This is 1350, 1350 meters or 1.35 kilometers. That's the distance or the displacement in this case. Okay, let's see the next part. So next part says an object starts from rest and accelerates at 2.5 meters per second square for 12 seconds. It then moves with a constant velocity for 8 seconds and finally decelerates at 6 meters per second square until it comes to rest. Okay, so in this part they've given all values in terms of acceleration and we need to draw the velocity time graph. So let's do a quick graphing of the acceleration, then we'll move on to velocity time graph that is asked. So A is on y-axis, time is on x-axis. So 2.5 meters per second square for 12 seconds. So something like this for 12 seconds. Then moves with a constant velocity for 8 seconds. So 0 acceleration for 8 seconds at 20. Then it decelerates at 6 meters per second square until it comes to rest. So -6 for until it comes to rest. We don't know the value of time in that case. Okay. So in this case, we'll have to do some calculations and find the values of velocity so as to draw the graph. Although if we want to look at the nature of the graph, we can definitely see that. So acceleration is constant between 0 to 12. That means velocity would be, acceleration is constant and positive. So velocity would be positive and increasing. So velocity would be something like, starts from 0, starts from rest, it is written. So rest goes up, velocity goes up, then velocity stays constant. Then velocity goes down and it's saying it comes to rest. So the graph is going to look like this, a perfect trapezium. Now let's see with the values. What are the values we get? Okay. So starting with 0, u is equal to 0. And then acceleration A is 2.5. T is 12. So V is equal to 0 plus AT. 12 times 2.5 is going to be 30 meters per second. Okay, 25 times 12 is 300, so 30 meters per second. This is the velocity at the end of t is equal to 12 seconds. It then moves with a constant velocity. That means 30 meters per second constant velocity for 8 seconds. Okay, and then finally decelerates at 6 meters per second square until it comes to rests. So this can be done orally as well, like verbally. You have a constant velocity of 30 meters per second at the end of t is equal to 20 seconds. So it first increases up till 30, then stays at 30 for 8 seconds more, and then at t is equal to 20 it starts decelerating at 6 meters per second square. That means with each second the velocity is going down by 6 meters per second. In how many seconds will it go to 0? 5 seconds. Because 5 times 6 is a 30. So in 5 seconds it's going to go down to 0. That means the rest period would be after 5 seconds. So 20, 25. This is going to be 25 seconds. Okay. Now we can draw the VT graph. Let's remove these. This was 20. Okay. So this is now V, velocity. 0, 30. Drawing a horizontal guideline here. Okay, and then vertical guidelines. Cool. From 0 till 30, first leg. 30 constant for 8 seconds, second leg. From 30 to 0, third leg, 5 seconds. Okay, now we need to find the total distance. Again, the total distance and total displacement would be same because no negative velocity component is there. So this trapezium O, A, B, C, let's say. Okay, so 1 by 2 sum of parallel sides, AB plus OC. AB is 8 seconds plus OC, the total time 25 seconds. Then distance between them, that is, let's say I name this as D, AD, that is 30. 25 plus 8 is a 33 times 30 over 2. That means 33 times a 15 which is equal to 15 times 3 is 45, 5, 4, 15 times 3, 45, and 4, 49. 495 meters, approximately half a kilometer. That's the distance covered in this case. Okay, let's see the next part. Part C. A particle accelerates uniformly from 11 meters per second to 26 meters per second with acceleration 0.5 meters per second square. It then decelerates at 2 meters per second square until it comes to rest. Okay, so two legs of motion. Initially it accelerates uniformly from 11 to 26 for some time, and then it decelerates until rest. Okay. Now this time the particle is not starting from zero velocity, it's starting from 11 meters per second. But we don't know the exact time for which this acceleration continues, but they've given us the values, enough values to calculate the time. So acceleration is basically v final, or v minus u over t. We're given a, v and u. So a is 0.4 is equal to v 26 minus 11 is 15 over t. So t is 15 over 0.4, which is 150 over 4. That's going to be 12, 30, 28, 24, 37.5 seconds. So it accelerates for this much time, okay, and then it decelerates at 2 meters per second square until it comes to rest. So let's calculate that time as well. So the final velocity is 26 meters per second, sorry, initial. For the second leg, the initial is 26 meters per second and final is at rest, so 0. And the deceleration is 2 meters per second square, so the time. So deceleration negative 2 is equal to final is 0 minus initial is 26 over t. Negatives cancel. T is equal to 26 over 2 or 13 seconds. 13 seconds. That is the second leg of motion. So now let's place these values. Let me clear this up a bit. Okay. So we put velocity on the y-axis, since we are asked to draw the vt graph, and time on the x-axis. It starts from 11. Let's say 11 is here, 26 is here. Horizontal guidelines. Then vertical ones. Time instance 0, 37.5, first leg ends, and another 13 seconds. Another 13 seconds, that means 50.5. It's at here. Okay. So now let's see. It goes from 11 to 26. This is it. 11, 26 meters per second. Then it goes from 26 to 0. Okay. So this is the VT graph. Again, to find the distance or the displacement, which are same in this case, we'll divide this into suitable figures so that we can calculate the area easily. So this the best suiting figures are OA, B, C, D. So OABC, that's a trapezium. BCD is a triangle. So let's say BCD is a right angle triangle. Okay. Let's put the formulas for OABC. 1 by 2, the sum of parallel sides. Parallel sides are OA and BC. So 11 plus 26, 37, into distance between them multiplied by distance between them. That is OC, 37.5. And then half base is 13, CD, that's 13, into height, BC, 26. So 2 and 13, 13 squared is 169 plus 37 times 37.5 over 2. This is going to be 693.75. So let's add both of these together. 693.75 plus 169. So 693, 793, and then 790 is 850, 859, and 3 is 862.75 meters. 862.75 meters is the distance or the displacement here. Okay, so this is the end of the complete question. We've done 3 parts. I think this would be sufficient for you to have a good understanding of how to do the graphing. We've tried all kinds of graphs, the VD graph, AT graph. Okay, take care, bye bye. Like, share and subscribe to the channel and keep practicing.